In 1892, a 4-foot-tall hunchbacked immigrant arrived at Ellis Island with just $10 in his pocket. Immigration officials nearly turned him away. They couldn't have known that this seemingly disabled man would soon revolutionize the entire field of electrical engineering and become known as the Wizard of Schenectady. A genius whose calculations would power America into the modern age. This is the forgotten story of Charles Proteus Steinmetz, the mathematical mastermind who tamed lightning itself. Born Karl August Rudolf Steinmetz in 1865, Breslau, Germany, his early life seemed marked for tragedy. He inherited dwarfism and hunchback from his father, facing constant physical pain and societal prejudice. But young Karl possessed something extraordinary. A mind that could visualize complex mathematical patterns that others couldn't even comprehend. While studying mathematics at the University of Breslau, he discovered his true passion. The mysterious force of electricity that was just beginning to transform the world. But his brilliant future in Germany was threatened when his socialist writings caught the attention of Bismarck's anti-socialist laws. With police on his trail, he fled Germany in 1888, leaving behind everything he knew. After a harrowing journey through Switzerland and Italy, he arrived at Ellis Island in 1889, where he changed his name to Charles Proteus Steinmetz. Proteus, after the shape-shifting Greek god, a nod to his mastery of transformation, both personal and electrical. The America that Steinmetz encountered was in the midst of an electrical revolution, but one plagued by problems. Thomas Edison and others had begun electrifying cities, but they faced a massive obstacle. Alternating current systems were failing at an alarming rate. The mathematical complexity of a sea power was beyond the engineering knowledge of the time. Transformers would mysteriously burn out, causing blackouts and fires. The entire future of electrical power hung in the balance. But before Steinmetz could even begin to tackle these problems, he had to overcome the prejudices of his era. His unusual appearance drew stares and whispers. Job interviews ended before they began. Even his brilliant mind couldn't initially overcome the bias against his physical differences. Living in poverty on New York's Lower East Side, he might have given up if not for a chance meeting with Oscar Feldman, who recognized the young immigrant's genius and offered him a job at his electric company in Yonkers. It was here that Steinmetz would begin his transformation from refugee to revolutionary. But the greatest challenge still lay ahead: solving the mathematical mystery that was causing America's electrical systems to fail. Engineers of the time were using simple arithmetic to calculate power losses in electrical systems. Steinmetz knew this was wrong. Electricity didn't behave in straight lines, but in complex waves that required an entirely new mathematical approach. In 1893, Steinmetz published a paper that would change everything. He had discovered that magnetic materials under alternating current exhibited a property called hysteresis, a complex behavior that couldn't be calculated with traditional mathematics. While others saw this as an insurmountable problem, Steinmetz saw patterns. He developed a mathematical formula that could predict exactly how these materials would behave. The first practical application of complex numbers in engineering. Think about that for a moment. He could literally calculate the future behavior of electricity. His peers were stunned. Here was a man who could write equations that perfectly described the invisible dance of electrons. But Steinmetz wasn't done. He went on to develop a method called symbolic method of calculating alternating current, revolutionizing how engineers worked with AC power systems. This breakthrough allowed for the efficient design of electrical systems that wouldn't fail. Thomas Edison himself, who had famously opposed AC power, had to acknowledge the genius of Steinmetz's work. At General Electric, where Steinmetz now worked, he created the first artificial lightning laboratory, generating million-volt discharges to study how to protect power systems from lightning strikes. He became known as the Wizard of Schenectady, not just for his electrical wizardry, but for the way he lived, in a unique house with his adopted family, surrounded by his beloved greenhouse full of exotic plants, conducting experiments that would light up the night sky. Despite his revolutionary contributions, Steinmetz's name began to fade from public consciousness even before his death in 1923, while contemporaries like Edison and Tesla became household names. Steinmetz's complex mathematical approach to electricity, though more fundamental to our modern world, was harder for the public to grasp and celebrate. His physical appearance and unconventional lifestyle, living with his adopted family, refusing to marry, dedicating himself to socialist causes, made him an awkward fit for corporate marketing. General Electric, which had benefited enormously from his patents and innovations, gradually shifted their focus to more marketable figures. The very mathematics that made his work so revolutionary also made it difficult to explain to the general public. How do you make complex numbers and differential equations exciting to the average person? As the 20th century progressed, his contributions became fundamental but invisible, built into the basic infrastructure of electrical engineering. Taught in universities without much attention to their originator, his story became a footnote in engineering textbooks, his name familiar only to specialists in the field. But here's the reality that would amaze Steinmetz. Every time you flip a light switch, charge your phone, or power up your computer, you're using systems designed with his mathematical principles. His methods for calculating electrical phenomena are still taught in engineering schools today. The power grid that keeps our modern world running relies on his foundational work. His artificial lightning research laid the groundwork for understanding how to protect our electrical infrastructure from natural disasters. Perhaps most importantly, Steinmetz proved that physical limitations and societal prejudices don't define human potential. He transformed himself from a persecuted refugee into one of the most influential engineers in history. His story reminds us that true genius doesn't always come in the package we expect, and that the most important contributions to human progress often come from those society initially rejected. In an age where we celebrate disruptors and innovators, it's time to remember Charles Proteus Steinmetz, the wizard who made our electrified world possible. If you've been inspired by this forgotten genius, hit that subscribe button for more stories of the overlooked innovators who shaped our world. And leave a comment below sharing your thoughts on this remarkable man who proved that the power of the mind knows no physical limitations.